A very good evening to all my dear students. Uh, a special good evening to all of you who are wishing me in the chat section. This is my third session of organic chemistry, wherein we are discussing the first chapter in organic chemistry, first PUC, which lays the foundation for your entire organic chemistry course. Today will be the last session in this chapter. We'll be completing it. This Sunday, you'll be writing a test in chemistry and mathematics, CET test of full length 60 questions, 1 hour, okay, on these topics. So please be attentive and focus in this class. ಇವತ್ತು ಕ್ಲಾಸ್ ಅಲ್ಲಿ ನೀವು ಸರಿಯಾಗಿ ಪಾಠ ಕೇಳಿದ್ರೆ ಮತ್ತೆ ಅದನ್ನು ಓದಬೇಕಾಗಿಲ್ಲ. You can straight away practice some questions and get into the test. Okay, so let me start. Let me give you a quick recap of what was done in the previous class. We solved some multiple choice questions related to IUPAC nomenclature, and then we also discussed electronic effects, under which we have two categories: permanent effects and temporary effect. Under permanent effects, we have three types: inductive, resonance, hyperconjugation. And under temporary effects, you have what is known as electromeric effect. That is what is the slide you are seeing here. Okay. Now we will begin the session today by solving multiple choice questions on electronic effects, and then we'll look at the other aspects or other concepts in the chapter. Okay. And today we will also be sending you one small assignment section on this chapter. Okay, around 30 questions irutte, so that will be a good practice before the test. And I will also send the synopsis along with the working I have done for the worksheet. Worksheet na nimge group alli post madidvi. At the same time, I will also be sending the questions. Nanenu nimge ಈಗ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಇದೀನಿ, ಅದರ ಕಾಪಿನೂ ಒಂದು ಕಳಿಸ್ಕೊಡ್ತೀನಿ, so that you can revise with those questions also. Okay, right. Let us now start solving multiple choice questions. Okay, this was the electronic effect part that we discussed last class, like inductive and this one resonance effect. Electromeric effect can also be positive and negative. Okay, yes. Question number 13. Question number 12 was still IUPAC nomenclature. Question number 13 is for electronic effects. Okay, let's take up this question now. Question number 13. Let me highlight this. Homolytic fission. We all know what homolytic fission is. It is a type of bond breakage, covalent bond breakage, wherein both the participating atoms part away with one electron each. They would take away one electron each. Okay, so you should now you find out such a homolytic fission leads to what kind of species. Yav tharad species produce agutte. Will it be ions? Will it be radicals? If it's ions, it's only negative ions, or will it be only positive ions, or both? Check this out. Homolytic fission. Let me give you an illustration. Carbon. Let's say there is one more carbon atom here. If you are successful in carrying out homolytic fission of this bond, the bond will break such a way that the two participating atoms will take away one electron each. This will now result in species wherein each carbon atom will have an odd electron or an unpaired electron. Now, what do we call such species as? We call them free radicals. Free radicals. So free radicals are neutral species. They don't carry any charge. These are highly reactive. Neutral and matra reactivity no kadme iralla. These are highly reactive. Okay, highly reactive neutral species. Highly reactive neutral species. Let me see what is being given in the chat section. Okay. There is a question: which time will the test be conducted? All information related to test will be told to you well in advance. Don't worry. Okay. Yes. So therefore, for question number 13, Answer is neutral species. 2 neutral species are formed. Just a second. Let me highlight the answer now. Yes. 2 neutral species are formed. This will be the answer. Okay. Question number 14 now. Which of the following is an electrophile? Come on. Send me the answers in chat section. Let me see. Which of the following is an electrophile? Last option, let me make a small correction there. It's not AlCl4. It is AlCl4 minus. Okay. Let me see who's answering correctly. Okay. Roja says B. Bhuvaneshwari. Yamanakshi. Yamanakshi says A. Roja says B. Bhuvaneshwari says B. Okay. Let us now see. Akshata says B. Again, answer na chat alli ಕಳಿಸೋದಕ್ಕೆ ಮುಂಚೆ question number type, so that I'll get to know for which question you're answering ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ ನನಗೆ. Okay. Majority of you are suggesting B. Okay, let me see. Which of the following is an electrophile? Please do remember, electrophiles are species which accept electrons. Okay, they seek electrons. They're electron deficient. Now, methanol has oxygen with 2 lone pairs. It will act as a nucleophile. Ammonia has 2 lone pairs. AlCl4 minus is negatively charged. It has its octet complete. It is BCl3, boron trichloride. Will have incomplete octet. Complete octet. And therefore, this should be the electrophile because it's ready to accept electron. It's electron hungry. Okay. Hence, this is the electrophile. Only a few of you have answered it, not all. BCl3. Right. That was the answer for question number 14. Now let's go to question number 15. Okay. This is regarding resonance. Resonance ಬಗ್ಗೆ ನಾವು last session ಅಲ್ಲಿ ಕಲ್ತ್ಕೊಂಡಿದ್ವಿ. Resonance ಬಗ್ಗೆ ತಿಳ್ಕೊಂಡಿದ್ವಿ. Resonance phenomena ಏನು, ಯಾವ ಕಾಂಪೌಂಡ್ಸ್ ರೆಸೊನೆನ್ಸ್ ಎಕ್ಸಿಬಿಟ್ ಮಾಡುತ್ತೆ, ರೆಸೊನೆನ್ಸ್ ಎಫೆಕ್ಟ್ ಕಾನ್ಸಿಕ್ವೆನ್ಸ್ ಏನು, ಇವೆಲ್ಲ ನಾವು ಹಿಂದಿನ ಸೆಷನ್ ಅಲ್ಲಿ ತಿಳ್ಕೊಂಡಿದ್ವಿ. ಓಕೆ, ಸೊ ಯು ಕ್ಯಾನ್ ಪುಟ್ ದಟ್ ಇನ್ ಟು ಯೂಸ್ ಹಿಯರ್. ದ ಮಾಲಿಕ್ಯೂಲ್ ವಿತ್ 2 equivalent resonance structures is 2 equivalent resonance structures. Equivalent resonance structures andre they should have the same kind of bonds and the same type of charge separation as well. Okay, now there is a small printing discrepancy here. This is a pi bond. Okay, oxygen carbon oxygen double bond idu. Just let me make a small correction there. It's a carbon oxygen double bond. If it's not clearly visible, I'm rewriting it. All this is carbon oxygen double bond. Now you have to find out for which of the 4 you'll have equivalent structures. I told you what equivalent is. Same bonding arrangement, same charge separation. Okay, like the first one, option A. Option A check mark. H, C, NH2. First of all, will it show resonance? Resonance exhibit ಮಾಡುತ್ತಾ? Check it. Lone pair on nitrogen is involved in conjugation or resonance. The pi electrons of the carbonyl group. See, so I can write the resonance structures as resonance structure na ಹೀಗೆ ಬರಿಬಹುದು. H, C ಇದು ಹಾಗೆ ಇರುತ್ತೆ, ಏನು ಚೇಂಜ್ ಇಲ್ಲ. ಬಟ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಇಲ್ಲಿ ಕಾರ್ಬನ್ ಆಕ್ಸಿಜನ್ ಡಬಲ್ ಬಾಂಡ್ ವಿಲ್ ನೌ ಬಿ ಕಾರ್ಬನ್ ಆಕ್ಸಿಜನ್ ಸಿಂಗಲ್ ಬಾಂಡ್. ಯಾಕೆ ಅಂದ್ರೆ pi electrons have moved to the pi electron density has moved towards oxygen, making it negatively charged. Negative charge ಆಗುತ್ತೆ. And look at this, carbon nitrogen single bond ಏನಿತ್ತು ಅದು carbon nitrogen double bond ಆಗುತ್ತೆ because nitrogen is donating lone pair. And any atom which donates lone pair, one second, just a second. Yeah. So I was telling you, any atom which donates lone pair will get a positive. This will get a positive charge. Now, can we say are the two structures equivalent? Sadhyane illa. Yake andre, in the structure on the left, you have no negative charge on oxygen. Oxygen will negative charge illa. Whereas structure on the right has a negative charge on oxygen. Structure on the left has no charge on nitrogen, whereas structure on the right has positive charge. So the two structures are not equivalent, but they are resonance structures. They are resonance structures. So you can say not equivalent. Not equivalent. Okay. ಇದೇ ತರ ಅನಲೈಸ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ ಯಾವ ಸ್ಟ್ರಕ್ಚರ್ ಗೆ ಈಕ್ವಿವೆಲೆಂಟ್ ರೆಸೊನೆನ್ಸ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಬರೀಬಹುದು ಅಂತ. ಓಕೆ, ಬಿ ಎಚ್ ಬಿ ಎಚ್ ಸಿ ಡಬಲ್ ಬಾಂಡ್ ಓ minus. Okay, now let me write the resonance structure here. Observe, negative charge is in conjugation with double bond again. So how will I write the resonance structure? H single bond carbon. Now instead of carbon oxygen double bond, you have carbon oxygen single bond. Again same thing has happened. Oxygen has withdrawn or taken away the pi electron density, making it negatively charged, and this carbon oxygen single bond will now be double bond. You structure on the left and structure on the right compare madi. Left ಮತ್ತು right compare madi. They look equivalent. See, oxygen has a negative charge. Here also oxygen has a negative charge. There is a doubly bonded oxygen on the structure. On the structure on the right also there is a doubly bonded oxygen. So yes, they are equivalent. Equivalent structures. That's what we were asked to find out. We were asked to find out which is equivalent. So B will be the answer. Mark it. Correct answer will be B. But out of curiosity, let's also check C and D. Okay, C check. If you check C, see in the exam, ನಿಮಗೆ ಒಂದ್ಸತಿ ಆನ್ಸರ್ ಬಂತು, ನೀವು ಮತ್ತೆ ಬೇರೆ ಆಪ್ಷನ್ಸ್ ನ ವೆರಿಫೈ ಮಾಡಬೇಕಾಗಿಲ್ಲ. You can proceed to the next question. But while studying, while preparing for the exam, please also know why the other options are wrong. Apart from the correct answer, why the other options are wrong. ಬೇರೆ ಆಪ್ಷನ್ಸ್ ರಾಂಗ್ ಯಾಕಾಗಿದೆ ಅಂತ ಕೂಡ ತಿಳ್ಕೊಳ್ಳೋದು ಬಹಳ ಮುಖ್ಯ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ಸಿ ವಿಲ್ ಬಿ ಎಚ್ COOH, lone pair. See again, same kind of resonance involvement. H CO minus double bond OH plus. So again, they are not equivalent. So this is not the answer. Option D, check out option D. Option D is HCOCH3. I think it's CH3. Let me just shift this toolbar. Yes, it is CH3. Now look at option D. In option D, there is no resonance possibility at all. Resonance illa, delocalization sadhyane illa. No resonance at all. No resonance phenomenon or resonance effect. Phenomenon, yes. So that's about option D, and this is how you analyze question number 15. So for question number 15, answer is B. Now we'll go to the next question. Okay, carbon carbon single bond and carbon carbon double bond lengths are equal in. This is a nice question. Carbon carbon single bond, carbon carbon double bond lengths are equal in. Okay, check it out. First, let me write option A. Option A, buta 1,3-diene. Let me write the structure of buta 1,3-diene. CH2, double bond, CH, single bond, CH, double bond, CH2. This is called buta 1,3-diene. Okay. Now, this compound shows resonance. I can write resonance structures like this. wherein double bond or pi bond shifts, double bond here CH, single bond CH2. Since this carbon is taking away pi electrons, it is negatively charged, and this carbon will be positively charged. Okay. Yeah, I have a request to all the participants. Please turn off your video. If we find anyone turning on your video, you will be kept out of the meeting room. Okay. So please cooperate. Please cooperate. It is for your benefit also. If you turn on your video, there will be a lot of data consumption. Nim kadeinda. Okay. So therefore, please turn it off. Yes. Here, because of resonance, as you can see, carbon-carbon double bond in one structure is not carbon-carbon double bond anymore. It is carbon-carbon single bond. So delocalization ensures all bond lengths are equal, because the actual bond length here will be that of single bond and double bond. So in this case, all bond lengths are equal. All bond lengths are equal. So this looks to be the correct answer. But we'll verify the other options also. B, cyclopentene. No. B. Let's say this is cyclopentene. Cyclopentene. No resonance, no delocalization. So this double bond is localized. Hence, you'll have two types of bond length here. One carbon-carbon double bond irutte, ಇನ್ನೊಂದು carbon-carbon single bond. So there are two bond lengths. Bond lengths are not equal. Bond lengths not equal or unequal. Option C ನೋಡೋಣ. cyclohexavanthridine. See, ಇಲ್ಲಿ ನಿಮಗೆ names in the structure ಬರೀದ್ ಗೊತ್ತಿರಬೇಕು. ಅದು ಗೊತ್ತಿಲ್ಲದೆ ಇದ್ರೆ ನೀವು ಆನ್ಸರ್ ಮಾಡಕ್ಕಾಗಲ್ಲ. You should know how to write the structure of an organic compound from its name. So cyclohexavanthridine ಅಂದ್ರೆ this one. Cyclohexa 1,3 First position there is a double bond. 1, 2, 3. Third position there is a double bond. Cyclohexa 1,3 Here conjugation or resonance is only operational till here. These carbon atoms, this carbon atom is not involved in conjugation, which means again bond lengths are unequal. Bond lengths unequal. Okay. Option D, anyways, none of the options. Okay. So it is option A that is the correct answer. Option A. Let me highlight it. Option A. Buta 1,3 diene. Yes. Next question number 3. Which one of the following sets contains substituents only with minus R effect? We discussed it. Plus R effect eno, minus R effect eno, yav groups plus R effect exhibit ಮಾಡುತ್ತೆ, yav tharad groups minus R effect exhibit ಮಾಡುತ್ತೆ, ಅವೆಲ್ಲ discuss ಮಾಡಿದ್ವಿ. Here is a question on that. How to identify plus R and minus R effect, or which set here has only minus R groups? We'll check it out one by one. Okay. Option A. In option A, first one, see, nitrogen, which is attached to the conjugated system, has a lone pair. Let me repeat it. Please recollect. A group in which atom directly attached to the system, conjugated system, if it has one or more lone pair, then it is plus R. So this is plus R. Author plus R groups yesterday. Okay. At the same time, if an atom attached to the conjugated system is in turn attached to another electronegative atom by a multiple bond, it becomes minus R. So nitro group minus R ಆಗುತ್ತೆ. ಅದೇ ತರ CHO ನೋಡಿ, ಇದನ್ನ ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಮಾಡಬೇಕು. CHO ಅಂತ ಹಾಗೆ ನೀವು ಆಲ್ಫಾಬೆಟ್ಸ್ ನೋಡಿದ್ರೆ ಗೊತ್ತಾಗಲ್ಲ. You have to expand structure. CH double bond O. CH double bond O. Okay. Now see, the atom attached to the system is in turn attached to oxygen through a multiple bond. This also is minus R. But a question you have to find out or identify that set in which all groups are minus R. Yalla groups minus R irbeku. Okay, but here only 2 groups are minus R. Therefore, not possible. Option B. Again, you have lone pair on oxygen, making this plus R. Cyanide minus R. RO, lone pair on oxygen, plus R. So this also is not the correct answer. Then COOR, ester group. Look at this. Carbon attached to more electronegative oxygen. So minus R. COOH, ಇದನ್ನ ಈ ತರ ಬರಿಬಹುದು. C double bond OH. Again, carbon attached to electronegative oxygen, minus R. Nitrosyl group, NO, is also minus R. So here, all the 3 groups are minus R. So this must be a correct answer. One second. I'll highlight it. Option C is our correct answer. Good. Again, option D, correct answer bandide, but still out of curiosity, we'll check option D. NR2, lone pair, plus R. CHO, we had already found out it. We have already found it out. Minus R. COCl, acid chloride, same, minus R. But the only option which has all groups minus R is C. So C is the correct answer. Hope you all have understood this. Next. Question number 18. Question number 18. In which of the following molecules pi electron density in the ring is minimum? Pi electron density in the ring is minimum. ಇದನ್ನ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು ಅಂದ್ರೆ ಒಂದ್ ಸ್ವಲ್ಪ ನಿಮ್ಗೆ ಪ್ಲಸ್ ಆರ್ ಎಫೆಕ್ಟ್ ಮತ್ತೆ ಮೈನಸ್ ಆರ್ ಎಫೆಕ್ಟ್ ಬ್ಯಾಕ್ ಗ್ರೌಂಡ್ ಗೊತ್ತಿರಬೇಕು. ಅದಕ್ಕೆ ನೀವು ನನ್ನ ಹಿಂದಿನ ಕ್ಲಾಸ್ ನ ವಿಡಿಯೋ ಮತ್ತೆ ನೋಡಿ. And those who have already present in the class, you can recollect plus R effect. Plus R effect usually increases electron density on the ring. Increases electron density on the ring. Whereas minus R effect, minus, the symbol signifies it. Minus R means the group is withdrawing electrons from the system. Minus R effect will decrease electron density on the ring. Decreases electron density on the ring. Okay, plus R effect, minus R effect. Now, it's just that you should find out which is the plus R group, which is the minus R group. You'll notice NO2 minus R, whereas NH2 amine group plus R. Here again, 2 minus R NO2 groups are there, minus R, minus R. Here OCH3 plus R. Again NO2 we know is minus R. So, in question kelideno, in which of the following molecules pi electron density in the ring is minimum? If electron density in the ring has to be minimum, then it must be attached to electron withdrawing minus R groups. Illi yav option alli minus R groups jaasti ide nodi. It's option D. It is 2 minus R groups. In ella options allu one minus R group ide athwa adr jotege one plus R group irutte. But option D has 2 minus R groups. Therefore, this should have the least electron density. Let me now mark it. Yes, this is the correct answer now. Option D. Very good. So, question number 18. Correct answer is option D. Okay. Let me see how many of you have given the correct answers for this. Okay, very good. Aishwarya, Ravi, Bhagyashree, Akshata, all of you given the correct answer is D. Very good. Next question, question number 19. One second. Yes. The stability of this compound given Me2C double bond CH2 is more than MECH2CH double bond CH2. So you are comparing the stability of alkenes. Stability of alkenes. Stability of alkenes is best explained by hyperconjugation effect. Hyperconjugation effect. Stability. Okay. So here the stability of these two compounds again can be explained by the hyperconjugation effect of methyl group. Look at this. Let me write the structure. Me andre ಗೊತ್ತಿರಬೇಕು ನಿಮಗೆ. Me andre methyl. Me stands for methyl. ಅದೇ ತರ ಕೆಲವು symbols use ಮಾಡ್ತಾರೆ. Et for ethyl. Then pH for phenyl. Bu for butyl. So you must be aware of some of these. Okay. Then let me write the structure. CH3, CH3, double bond, CH2. Now, this alkene is stabilized by hyperconjugation structures involving these alpha hydrogens. I have discussed this in the last class. Please go to the video again, okay? And you'll be able to easily answer these questions. Okay. So the answer is hyperconjugative effect of the methyl group. Hyperconjugative effect of the methyl group. Okay, next. Question number 20. The molecule which exerts, important question. The molecule which exerts inductive, mesomeric and hyperconjugation effect is. ಮೂರು effect ಇರೋ molecule ಯಾವುದು? The molecule which exerts inductive, mesomeric and hyperconjugation effect. Let me see. Send in the answers. Okay. Bhagyashree says C. Check ಮಾಡೋಣ. Pratiksha also says C. Okay. Roja says B. Ravi says option D. So A, B, C, D ಎಲ್ಲ ಹೇಳ್ತಾ ಇದ್ದೀರಾ. Okay. We'll check it out. We'll find out the answer. Okay. Let me again make it clear. Let me correct this. This is double bond. Okay. One second. Yeah. I'll rewrite it. C double bond O. Idu ashte. C double bond C. Now let's identify. Option A. Look at option A. Inductive effect is something which is there in all molecules. Inductive effect is universal. As long as there is electronegativity difference, there will be inductive effect. Electronegativity difference idre, there will be inductive effect. And electronegativity difference arises when there are atoms of different elements. So inductive effect is something you can expect in almost all. But in addition to inductive effect, ಏನಿದೆ ನೋಡ್ಬೇಕು ನೀವು. Resonance ಇದೆಯಾ, hyperconjugation ಇದೆಯಾ, ಏನಿದೆ ನೋಡ್ಬೇಕು. Okay. CH3, CH double bond C double bond O CH3. Okay, ಇಲ್ಲಿ ನೋಡಿ. While discussing hyperconjugation, I told you if there are alpha hydrogens. See, this is carbon with double bond. Attached to it is alpha carbon. This is alpha carbon. So these hydrogens are all alpha hydrogens. Alpha hydrogen atoms. They would be involved in conjugation with the pi bond. The carbon hydrogen sigma electrons will be involved in conjugation with the pi bond, which means if you find alpha hydrogens for a compound with double bond, then that compound shows hyperconjugation. So compound A, option A, shows hyperconjugation. Hyperconjugation, yes. Hyperconjugation, yes. Resonance ke condition, you know, I told this to you. There must be conjugation of pi electrons. Okay. Alternate single and double bonds. There is conjugation, alternate double and single bonds. Yes. Therefore, it also shows resonance. Resonance effect, yes. Again, inductive effect is something which is always there. Inductive also, yes. Inductive also, yes. So a compound A shows all the three effects. So this is right. Option A. One second. I'll mark it. Option A itself is the correct answer. Good. ಹಾಗೆ ಬೇರೆ ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ ಏನೇನು ಎಫೆಕ್ಟ್ ಇರುತ್ತೆ ಅಂತ ಸುಮ್ಮನೆ ವೆರಿಫೈ ಮಾಡೋಣ ಫಾರ್ ಅವರ್ ನಾಲೆಜ್ ಸೇಕ್. ಓಕೆ, CH3Cl only inductive. Inductive only. This compound resonance and inductive. No hyperconjugation. Resonance and inductive. No hyperconjugation. Option D, hyperconjugation and inductive. Hyperconjugation and inductive. Yes, right. So this is how you answer question number 20. Option A is the 20. Okay. Now coming to question number 21. Okay. Right. Pavan Nayak, you have. If you have any question, type the question in the chat section. I will read it out. Question in the chat section alli question type madu. Pavan, if you have raised your hand, type your question in the chat section. Okay. Noda ee question ge answer martira, yen answer martira noda. Question number 26. How many have answered this? Ramya says option C. I hope you are giving it a thought and then answering. I'm sorry. ಸುಮ್ಮನೆ ಯಾವುದೋ ಆಪ್ಷನ್ಸ್ ಮಾರ್ಕ್ ಮಾಡ್ತಿಲ್ಲ ತಾನೆ. I hope you are giving it a thought and then picking up the answer. Yes, most of you are suggesting C. Bhagyalakshmi, Jyoti. Yes, most of you are suggesting option C. Some of you are suggesting A. No. See, you can classify carbocations into 3 types. These are the 3 types. One second. Yeah. Carbocations can be classified into 3 types based on degree of substitution: tertiary, secondary, primary. Tertiary carbocation andre eno, it is the carbon with positive charge. If it is attached to 3 alkyl groups, 3 R groups and no hydrogen, it's tertiary. And carbon with a positive charge is attached only to 2 alkyl groups and 1 hydrogen, then it is secondary. Whereas carbon with a positive charge is attached only to 1 R group and 2 hydrogen atoms, it is then branded as primary. Now, using hyperconjugation and inductive both, order of stability of carbocations is based on hyperconjugation and inductive effects based on hyperconjugation and inductive effects. The order of stability of carbocations is carbocations is this: tertiary greater than secondary greater than primary. Tertiary greater than secondary greater than primary. Okay, right. Now here, see, let us find out which is tertiary, which is secondary, which is primary. Option C, nodi, carbon with positive charge is attached only to 2 alkyl groups, so secondary. Option B is tertiary. Option C is also tertiary. Option D is methyl. Okay, so you need to now decide between A and B. A and B madhya decide ಮಾಡಬೇಕು. ಹೇಗೆ? Here you make use of the concept of hyperconjugation. Check this. CH3 plus CH2 CH3. Always you find out the number of hyperconjugation structures from the number of alpha hydrogens. ಎಷ್ಟು alpha hydrogens ಇರುತ್ತೋ ಅಷ್ಟು hyperconjugation structures ಇರುತ್ತೆ. Okay, let's find out. So let's see, in this case, how many alpha hydrogens are there? Carbon with positive charge carbon attached to it is alpha carbon. Nodi, idu alpha carbon. This also is alpha carbon. This is also alpha carbon. So how many alpha hydrogens? Alpha hydrogen atoms is equal to 2 plus 3, 5, 5 plus 3, 8. 8 alpha hydrogens here. Yaudake option A ge. Option B ನೋಡೋಣ. Look at option B. Central carbon, CH3, CH3, CH3 with a plus charge. Again, this also has 3 alpha carbons. But see how many alpha hydrogens? 3 plus 3, 6 plus 3, 9. So alpha hydrogens will be equal to 9. Now remember this, greater the number of alpha hydrogens, greater the number of alpha hydrogen atoms, greater the number of alpha hydrogen atoms, more stable the structure is, okay? Higher the stability of the structure. Higher the stability. Yes. That's what it is. Okay. Good. So that's about question number 21. Okay. Let me check out question number 22. Yes. This is based on identifying the type of reaction. What type of reaction is this? Check this. Here, benzene C6H6 is losing one hydrogen and in its place you have Br. Let me rewrite this. Benzene with 6 hydrogen atoms is made to react with bromine in presence of FeBr3. FeBr3 gives you bromobenzene Br plus HBr. This is the given reaction. Andre, ee reaction alli hydrogen atom yellidyo alli bromine attach agutte. In other words, you can say bromine replaces hydrogen atom. Such a reaction is called a substitution reaction. Bromine substitutes for hydrogen. Remember, organic reactions can be categorized into following 3 types. Organic reactions. Following 3 types, okay, common types. Idalde bere categories ide. Nimma level ge beda adu, nimma syllabus level ge beda. Okay. It is addition, substitution, elimination. These are the 3 prominent types of organic reactions. ನಾನು ಆಗ್ಲೇ ಹೇಳಿದಂಗೆ ಇನ್ನೂ ಹಲವು ತರ ಇರುತ್ತೆ. ಪೆರಿಸೈಕ್ಲಿಕ್ ರಿಯಾಕ್ಷನ್ಸ್ ಅಂತ ಇರುತ್ತೆ, rearrangements reactions irutte, okay, but all that is not required at the PU level. These 3 are most common: addition, substitution, elimination. This reaction belongs to substitution category, and substitution reaction can be grouped further into 3 types. It can be a free radical substitution, or nucleophilic substitution, or electrophilic substitution. ನೀವು ಯಾವ ಥರ್ಡ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ರಿಯಾಕ್ಷನ್ ಅಂತ ಐಡೆಂಟಿಫೈ ಮಾಡಬೇಕು. ಓಕೆ, ಈಸಿ. ಸಿ, ಬೆಂಜೀನ್ ರಿಂಗ್ is electron rich. Benzene ring is electron rich, hence attracts an electrophile Br plus. Br plus is an electrophile. So since Br plus is an electrophile and that's what replaces hydrogen, this can be called electrophilic substitution. Electrophilic substitution. Yes, let me highlight it. 1 second. Electrophilic substitution reaction. Yes, it is option A. Sorry, option C. Yes, with this we complete all questions related to electronic effects. Electronic effects mugitu. Now we'll go to the last section this chapter, which is based on qualitative and quantitative analysis of an organic compound. Okay. Yes. Oh, there's one more question. Okay. We'll come. This reaction again. ನಾನು ಆಗಲೇ ಹೇಳಿದಾಗೆ, see, Br gets replaced by OH. OH is substituting for Br, so this must be again a substitution. Easy to identify substitution reactions. Option B is the answer. Okay. Yes. That is question number 23. Next. Yes. This brings us to the last part of the chapter. Now, dear students, just there is some internet issue. I'll just sort it out. Just give me a minute. Please stay in the meeting. Yes, dear students. Sorry for the trouble. Okay. Let us continue. I was talking about qualitative analysis and quantitative analysis. Qualitative analysis andre eno? It mainly refers to detection of the elements that make up an organic compound. So you are basically trying to find out what makes up this organic compound. What are the elements that make up this compound? Okay. ಏನಿದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳೋದು ಕ್ವಾಲಿಟೇಟಿವ್ ಅನಾಲಿಸಿಸ್, ಎಷ್ಟಿದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳೋದು ಕ್ವಾಂಟಿಟೇಟಿವ್ ಅನಾಲಿಸಿಸ್. ಪ್ಲೀಸ್ ಮೇಕ್ ದಿಸ್ ಡಿಸ್ಟಿಂಕ್ಷನ್. ಒಂದು ಕಾಂಪೌಂಡ್ ಅಲ್ಲಿ ಯಾವ್ಯಾವ ಎಲಿಮೆಂಟ್ಸ್ ಇದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳೋದು ಕ್ವಾಲಿಟೇಟಿವ್ ಅನಾಲಿಸಿಸ್. ಆ ಎಲಿಮೆಂಟ್ಸ್ ಎಷ್ಟು ಪರ್ಸೆಂಟೇಜ್ ಅಲ್ಲಿ ಇದೆ, ಎಷ್ಟು ಪರ್ಸೆಂಟೇಜ್ ವೆಯ್ಟ್ ಆಗಿರ್ಬೋದು ಅಥವಾ ಪರ್ಸೆಂಟೇಜ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ನಂಬರ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್, ಓಕೆ, ಅದನ್ನ ಕ್ವಾಂಟಿಟೇಟಿವ್ ಅನಾಲಿಸಿಸ್ ಅಂತ ಕರೀತಾರೆ. ಓಕೆ, ಫಸ್ಟ್ ಲೆಟ್ ಅಸ್ ಚೆಕ್ ಔಟ್ qualitative analysis, wherein we try to find out the different elements that make up an organic compound. In an organic compound, by default, you can expect carbon and hydrogen. That's a must, because all organic compounds are derivatives of hydrocarbon. Okay, just a second. Yeah, carbon and hydrogen is a must in an organic compound. In addition to carbon, hydrogen, you can have other elements also. You call them heteroatoms: oxygen, nitrogen, sulfur, halogens, phosphorus, and so on. Okay, these are some prominent ones. Now, how to detect these elements? You need to be aware of these processes, reactions, which will help you detect these. Okay? First and foremost, detection of carbon and hydrogen. Detection of carbon and hydrogen. How do we do it? Easy. If a given organic compound, when heated with copper oxide, see, if you heat it with copper oxide, that being an oxidizing agent, oxidizes the carbon and hydrogen in the compound to carbon dioxide and water. Careful, ಕೇಳಿಸ್ಕೊಳ್ಳಿ. The carbon and hydrogen content in an organic compound, when heated with cupric oxide, gets converted to their corresponding oxides, carbon dioxide, water. Carbon dioxide ಅಥವಾ water form ಆಗಿದೆ ಅಂತ ಹೇಗೆ ಪ್ರೂವ್ ಮಾಡೋದು? Easy. You all have done this experiment in a lab. Carbon dioxide passed through lime water, turns lime water milky. Lime water is calcium hydroxide. It turns lime water milky. That shows it's carbon dioxide. If it is proved that it is carbon dioxide, then it is an evidence for the presence of carbon. You pass this gas or vapor over copper sulfate. Copper sulfate is white in color. Anhydrous copper sulfate is colorless. Whereas if it picks up moisture, it becomes blue. That is how you can detect carbon and hydrogen. Heat the organic compound with cupric oxide. If carbon hydrogen is present, you'll have carbon dioxide water formed. How to detect carbon dioxide and water? Carbon dioxide is detected using lime water. Water can be detected using copper sulfate. Okay? Yes. That is how you detect carbon and hydrogen. Now, apart from carbon and hydrogen, I told you there are other elements. Bare elements kuda irutte. Okay? There are other elements as well. How do you detect those elements? there is one very important and a popular test which can detect several elements in one stretch. Okay, it's called Lessines test. Dear students, please mark it as a very important test that you have to know. CET questions baratte, NEET kuda questions baratte. This is very important. Okay, what is Lessines test? Illi ಏನು ಮಾಡ್ತೀವಿ? Check this. Let me explain the principle involved in Lessines test. What is it? Organic compounds usually are covalent molecules, and covalent molecules show very slow reactions, moderately occurring reactions. Reactions are occur at a moderate rate. This is a method wherein converting an organic compound to inorganic compound in Lessines test. Please note, organic compound converted to ionic compound, converted to ionic compounds, and ionic compounds react fast because these are reactions of ions. Ions will be charged, right? Charged species are highly reactive. Adinda reaction fast agutte. So you convert an organic compound into ionic compounds fast. Carry out test for those ions. If you show the presence of those ions, then you're indirectly proving the presence of these atoms. Just very simple. Example noting. If in your organic compound, carbon atom idde iruttalla by default. In addition to carbon, if nitrogen is also present, and if you submit the compound to Lessines test where the sample is fused with sodium, sample fused with sodium metal, and an extract is prepared. This is called sodium fusion extract. Sodium fusion extract or just fusion. Sodium fusion extract. Okay. Sodium, carbon, nitrogen gives you sodium cyanide, NaCN. Now, there are some tests to detect cyanide ion. If you get positive results there, then that proves the presence of cyanide ion. And cyanide ion present is anta prove adre carbon nitrogen is anta kuda prove agutte indirectly. That's the way to utilize this test. Okay. Similarly, let's say your compound has carbon, nitrogen as well as sulfur. Then by fusing it with sodium, what you get is sodium thiocyanide. If you prove the presence of thiocyanide ion, then it's like you're showing the presence of sulfur. Same thing applies to sulfur as well as halogen. Sulfur idre, it gets converted to sulfide. You can show its presence. Halogen idre, it gets converted to halide. You have reactions to detect halide ion also. So this is the logic or the principle involved in this test called Lessines test. Very important, as I told you. ಈಗ ನಾವು ಇದು reactions ಏನು ಅಂತ ನೋಡೋಣ. Which are those reactions which detect cyanide ion, hence proves existence of nitrogen? What are those reactions which detect thiocyanide ion, proving the existence of both nitrogen and sulfur? What are the reactions used for sulfur and halogen? We'll see all that. Okay. Next. Important. Okay. First, test for nitrogen. Test for nitrogen. Okay. One second. Yes. Okay. What is the test for nitrogen here? You know, sodium when fused with the organic compound gives you sodium cyanide. Okay. Sodium cyanide is formed. Now this cyanide, sodium cyanide in solution, okay, is made to react with ferric hydroxide. How is ferric hydroxide obtained? By the reaction of ferrous sulfate and sodium hydroxide. So ferrous sulfate reacts with sodium hydroxide to give you ferric hydroxide. That interacts with sodium cyanide to give you ferrous cyanide. Now this ferrous cyanide will further react with sodium cyanide to form complex compound sodium ferrocyanate. Sodium ferrocyanate anta one complex barutte. That further reacts with ferric chloride. You'll add ferric chloride to it, and that gives you this complex compound ferroferric or ferriferrocyanide. Ferriferrocyanide. It is having a characteristic Prussian blue color. It has a characteristic Prussian blue color. So this is how one can identify or test for nitrogen. Nitrogen aitu. Next, sulfur. Sulfur. How is sulfur detected? Sodium with sulfur gives you Na2S, sodium sulfide. And when sodium sulfide is made to react with sodium nitroprusside, E reagent ನೆನ್ಪಿಟ್ಕೋಬೇಕು ನೀವು. You should remember this reagent, sodium nitroprusside. So when fusion extract is made to react with sodium nitroprusside, you'll get a purple coloration indicating the presence of sulfur only. So test for nitrogen, test for sulfur. What if both sulfur and nitrogen are present? Check this. Test for nitrogen and sulfur. Erdu idre, this. You treat the compound which has SCN. Let me write it. It has to be SCN. Na is SCN. This compound is made to react with ferric ions, ferric chloride, that forms a red blood color, red blood precipitate, red blood colored precipitate. That indicates that it is ferricyanide, sorry, indicating presence of both sulfur and nitrogen. Then you have test for halogens. If chloride is present, upon treating it with silver nitrate, you get a white PPT. Okay. If bromide is present, upon treating with silver nitrate, you get a yellow PPT. And if iodine is present, upon treating with silver nitrate, you get this is a pale yellow PPT. This will be slightly darkish yellow PPT. Okay, iodine, indicating presence of iodine. Easy. Adhe thara phosphorus kuda detect ಮಾಡಬಹುದು. Here you treat the solution containing phosphate. First you convert phosphate organic compound to sodium phosphate from the fusion extract. From the fusion extract, you convert the phosphate into phosphorus into sodium phosphate. ಅದನ್ನ phosphoric acid convert ಮಾಡ್ತೀರಾ. ಈ reactions ಎಲ್ಲ practice ಮಾಡಿ ಒಂದ್ಸತಿ. Okay. Then you treat it with ammonium molybdate. Okay. You'll get a yellow PPT of ammonium phosphomolybdate, thus confirming the presence of phosphorus. ಈ ತರ ಎಲಿಮೆಂಟ್ಸ್ ನ ನೀವು ಡಿಟೆಕ್ಟ್ ಮಾಡಬಹುದು. Hope all of you understood this. Next. Okay, we'll answer a set of questions based on whatever we have studied so far. See, in addition to qualitative analysis, you also have certain purification techniques. Adenu anta helibidತೀನಿ ನೋಡಿ. Purification techniques. Let me write it here. Okay. Purification techniques of organic compounds. Purification techniques. Some of the common purification techniques are: 1, distillation, simple distillation. If organic compounds differ in their boiling point a lot, say 50-degree difference there, 60-degree difference there, you can carry out distillation, where you make use of difference in boiling point. Then you have fractional distillation. It's a more refined, more sophisticated version of distillation. Fractional distillation. ಇದು ಯಾವಾಗ ಯೂಸ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಮಿಕ್ಸ್ಚರ್ ಎಲ್ಲ ಕಾಂಪೋನೆಂಟ್ಸ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ತುಂಬಾ ಹತ್ರ ಇದ್ರೆ, ಅಂದ್ರೆ 10 degree difference, 50 difference ಈ ತರ ಇದ್ರೆ fractional distillation will be very helpful. Okay. Then you have other varieties. Let me write here 3. Steam distillation ಅಂತ ಇದೆ. Steam distillation. 4, you have vacuum distillation or distillation under reduced pressure. Vacuum distillation or distillation under reduced pressure. And you have crystallization techniques, which makes use of solubility difference. Crystallization, which makes use of differential solubility. Okay. And apart from this, you have what is known as chromatography technique. Chromatography technique. Okay, that's right. So this is all about purification techniques. Eega nodana. We'll check out questions. A compound which decomposes before its melting point can be purified by the method of. So if a compound is decomposing before its boiling point, compound boiling point reach ಆಗೋದಕ್ಕೆ ಮುಂಚೆನೆ decompose ಆಗ್ಬಿಟ್ರೆ, you can't use that boiling point difference method. So which method is best here? Anyone can tell me? Your answers ಹೇಳ್ತಿದ್ದಾರೆ ನೋಡೋಣ. Question number 24. Please type the question number and then give the answer. Okay, Hema says C. Swati says A. Vaishnavi also says C. Okay, 24th. Okay, Rakshita also says C. Okay, no. We'll check it out. Yes, all of you who said option C is a correct answer. Distillation under reduced pressure. What advantage is it? Distillation under reduced pressure. Please remember, a liquid boils when its vapor pressure reaches atmospheric boiling point, temperature at which vapor pressure becomes equal to atmospheric pressure. ಈಗ ಆ ಲಿಕ್ವಿಡ್ ಅಥವಾ ಆರ್ಗ್ಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ ಡಿಕಂಪೋಸಿಷನ್ ಪಾಯಿಂಟ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಮುಂಚೆನೆ ಇದ್ರೆ ಬಿಫೋರ್ ದ ಕಾಂಪೌಂಡ್ ಡಿಕಂಪೋಸ್, ಅದನ್ನ ಅವಾಯ್ಡ್ ಮಾಡಬೇಕು ಅಂತ ನೀವೇನ್ ಮಾಡಬೇಕು? You should reduce pressure. When you reduce pressure, external pressure is reduced, so liquid boils at a much lower temperature. Under reduced pressure, liquid boils at a lower temperature. Andre before its decomposition temperature. Ad yav temperature decompose agutto, decomposition temperature ಇಂತ ಕಡಿಮೆ ಟೆಂಪರೇಚರ್ ಅಲ್ಲೇ ಇದು ಬಾಯ್ಲ್ ಆಗುತ್ತೆ. ಅವಾಗ the compound will be safe. It will boil, vaporize. It will not decompose. That is the whole idea of distillation under reduced pressure. Question number 24. One second. Distillation under reduced pressure. Option C. Distillation under reduced pressure. Great. That is option C. Question number 24. ಆಯ್ತು. Question 25 ಎಲ್ಲರೂ ಆನ್ಸರ್ ಮಾಡಬಹುದು. The compound that does not give, ತುಂಬಾ ಕೇರ್ಫುಲ್ ಆಗಿ ಯೋಚನೆ ಮಾಡಿ ಆನ್ಸರ್ ಮಾಡಿ. Compound that does not give a blue color in Lessons test. Usually Lessons test blue color ಯಾವ್ದಕ್ಕೆ ಬರುತ್ತೆ? Element nitrogen. See, Prussian blue. Let me write it. One second. Element nitrogen when present as cyanide, sodium cyanide, gives Prussian blue in Lessons test. Lessons test. ಅಂದ್ರೆ ಇಲ್ಲೊಂದು ಕ್ಲೂ ನೀವು ಐಡೆಂಟಿಫೈ ಮಾಡಬೇಕು, ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಇದು. ಸೈನೈಡ್ ಫಾರ್ಮ್ ಆದ್ರೆ ಮಾತ್ರ ಪ್ರುಷಿಯನ್ ಬ್ಲೂ ಕಲರ್ ಬರುತ್ತೆ. ಅಂಡ್ ಫಾರ್ ಸೈನೈಡ್ ಟು ಬಿ ಫಾರ್ಮ್ಡ್, both carbon and nitrogen to be present. Okay, for Prussian blue color to be formed, carbon and nitrogen to be present. Carbon and nitrogen to be present. ಇಲ್ಲಿ ಏನ್ ಕೇಳಿರೋದು, ಯಾವ ಕಾಂಪೌಂಡ್ ಲೆಸೈನ್ಸ್ ಟೆಸ್ಟ್ ಎಕ್ಸಿಬಿಟ್ ಮಾಡಲ್ಲ ಅಂತ. ಓಕೆ, ಒನ್ ಸೆಕೆಂಡ್. ಯಾ, just a second. So let's now check out your chat response. 25 ಗೆ ಏನೇನ್ ಆನ್ಸರ್ ಹೇಳಿದಾರೆ ನೋಡೋಣ. Venkatesh Prasanna says B. Okay, Swati says option C. Varun Kumar says option C. Aishwarya D. Okay, C ಜಾಸ್ತಿ ಹೇಳಿದಾಗ ಕಾಣ್ತೀರಾ. ಓಕೆ, ನೋಡೋಣ. See, ಅನಾಲಿಸಿಸ್ ತುಂಬಾ ಸಿಂಪಲ್ ಇಲ್ಲಿ. ಆರ್ಗ್ಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ ಅಲ್ಲಿ ಕಾರ್ಬನ್ ನೈಟ್ರೋಜನ್ ಎರಡೂ ಇದ್ರೆ then it will show Lessons test for nitrogen. That is Prussian blue color. So ಯಾವ ಆರ್ಗ್ಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ ಅಲ್ಲಿ ಕಾರ್ಬನ್ ನೈಟ್ರೋಜನ್ ಎರಡು ಇಲ್ಲ ಅಂತ ನೋಡ್ಬೇಕು. ಬಿಕಾಸ್ ಇಲ್ಲಿ ಕೇಳಿರೋದೇನು, which does not give. And let's see, aniline ಫಾರ್ಮುಲಾ ನಿಮ್ಗೆಲ್ಲರಿಗೂ ಗೊತ್ತು. ಅಮೈನ್ಸ್ ಚಾಪ್ಟರ್ ಓದಿದ್ದೀರಾ? It is C6H5NH2. Yes, carbon and nitrogen both are present. Glycine amino acid, you have studied this in proteins. It is NH2 CH2COH, contains both carbon and nitrogen. It will show blue color. Hydrazine nodi NH2 ಇಲ್ಲಿ ಕಾರ್ಬನ್ ಇದೆಯಾ? ಇಲ್ಲ, there's no carbon, hence this does not show Lessons test. This Does not show Lorentz test. Hydrazine. Okay, that's it. That's about question number 29. Now we'll go to question number 26. The compound in the positive test for nitrogen with Lorentz solution of an organic compound is, we have discussed this. Positive test for nitrogen is Prussian blue color. Positive test for nitrogen is Prussian blue color. Prussian blue. And what's the composition for Prussian blue? Ferrocyanide. Ferrocyanide. Option D. Fe4, FeCN6 is option D. One second. That's about question number 26. Very good. We are coming to the end of this worksheet and this chapter also. We'll now go to the last section. Last section is quantitative analysis. ಇಲ್ಲಿವರೆಗೂ ನಾವು ಕ್ವಾಲಿಟೇಟಿವ್ ಅನಾಲಿಸಿಸ್ ನೋಡಿದ್ವಿ. ಯಾವ ಎಲಿಮೆಂಟ್ಸ್ ಇದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳೋದಕ್ಕೆ ಕೆಲವು ರಿಯಾಕ್ಷನ್ಸ್ ನ ಕಂಡಕ್ಟ್ ಮಾಡ್ತೀವಿ. ಬೇಸ್ಡ್ ಆನ್ ದ ರಿಸಲ್ಟ್ ವಿಲ್ ಕಮ್ ಟು ಸಮ್ ಕನ್ಕ್ಲೂಷನ್ಸ್. ಈಗ ನಾವು ನೋಡಬೇಕಾಗಿರೋದು ಕ್ವಾಂಟಿಟೇಟಿವ್ ಅನಾಲಿಸಿಸ್. Once you find out what are the elements present, you should find out what is their percentage by mass. Because if you know that, ಅದು ಗೊತ್ತಿದ್ರೆ ನಿಮ್ಗೆ empirical formula find out ಮಾಡಬಹುದು. You can find out empirical formula, and knowing empirical formula you can find out molecular formula. Let's check it out. Yes, quantitative analysis. Yes, just give me a minute. Yeah, quantitative analysis. Okay, so here you are finding out how much of the elements are present. Now there is a method called Liebig's method for the detection of carbon and hydrogen. To detect carbon and hydrogen, you have what is known as Liebig's method. How do you find out the amount here? Let me explain the principle. See, ನಿಮಗೆ CET ಮತ್ತೆ NEET exam ಅಲ್ಲಿ ಪ್ರೊಸೀಜರ್ ನೇನು ಡಿಸ್ಕ್ರೈಬ್ ಮಾಡಬೇಕಾಗಿಲ್ಲ. So don't worry too much about the procedure. Understand the principle. It is enough for you to solve MCQs. Okay. Adana board exam al keltare. And you anyway are not writing the board exam now. So look at Liebig's method principle. Let me select the pen here. 1 second. Yeah. You first weigh the organic compound. This is a must. This is important. You should weigh the organic compound. You should know what mass of organic compound you begin with. Then heat it in presence of pure oxygen. All the carbon in the organic compound gets converted to carbon dioxide, CO2, and all hydrogen in the organic compound gets converted to water, H2O. Now you measure the mass of carbon dioxide and water formed. From that, find out percentage of carbon. Percentage of carbon andre for 100 grams of the compound, what mass is carbon? Percent means for 100. ಪ್ರತಿ 100 ಗ್ರಾಮ್ಗೆ ಎಷ್ಟು ಕಾರ್ಬನ್ ಆಟಮ್, ಎಷ್ಟು ಕಾರ್ಬನ್ಸ್ ಇರುತ್ತೆ, ಎಷ್ಟು ಗ್ರಾಮ್ಸ್ ಕಾರ್ಬನ್ ಇರುತ್ತೆ ಅಂತ. ಓಕೆ, ದಟ್ ಕ್ಯಾನ್ ಬಿ ಫೌಂಡ್ ಔಟ್ ಬೈ ದಿಸ್ ಸಿಂಪಲ್ ಫಾರ್ಮುಲಾ. Percentage of carbon is equal to 12. You know, where do we get this number 12 from? Atomic mass of carbon 12 into mass of carbon dioxide. ಈ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಇಂದ ನೀವು ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಜನರೇಟ್ ಮಾಡಿರ್ತೀರಾ, ಅದರ ಮಾಸ್ನ ಕಂಡು ಹಿಡಿದಿರ್ತೀರಾ. Divided by 44. Where are you getting this number 44 from? Molecular mass of carbon dioxide into mass of organic compound, which you had weighed in the beginning. I told you, right? Before starting the experiment, you should have weighed the compound. That is the mass of organic compound. And this must be multiplied by 100 at the end. That's when you get it as a percentage for every 100. This is the formula you're supposed to use to find out carbon. Okay. Similarly, you have a formula to find out estimate percentage of hydrogen. How is it? Check it out. Percentage of hydrogen is equal to 2. Now, can anyone type in the chat section why I am taking 2 for hydrogen? Hydrogen get 2 ಯಾಕೆ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇದೀವಿ? Its atomic mass is 1. ನೆನಪಿಟ್ಕೊಳ್ಳಿ. Hydrogen atomic mass 1. But why are we taking 2 here? Anybody? Again, question ಕೇಳಿದ್ದಾರೆ. What is 44 ಅಂತ? 44 is molecular mass of carbon dioxide. Carbon dioxide molecular mass. Yes, Venkatesh, Ravi, you all are right. Water contains 2 atoms here. One molecule of water contains 2 hydrogen atoms. To account for that, you take 2 here. Simple. Okay. Carbon dioxide, 1 mole of carbon dioxide contains 1 mole of carbon. Therefore, you take 12. Ade water tagondre, 1 molecule of water has 2 hydrogen atoms. Therefore, you take 2. Simple. Mass of water, which you have found it out in the experiment, divide by 18. 18 ಯಾಕೆ ಹೇಳಿ ನೋಡೋಣ. Come on. Why 18? Let me see who will answer. Why I am taking 18 in the denominator? Just type in the answer. 18. One of you have requested for question number 21 to be explained again. I will do it. Yes, Hema. Hema is correct. Swati, yes. Molecular mass of water. Suchitra, correct. Molecular mass of water. Molecular mass of water is 18. That's like how I have taken molecular mass of carbon dioxide. Here I have taken molecular mass of water. That's all. Into same mass of organic compound. E formula ನೆನಪಿಟ್ಕೋಬೇಕು. Because this will help you to find out percentage of carbon and percentage of hydrogen easily. See, in case ನಿಮಗೆ ಫಾರ್ಮುಲಾ ನೆನಪಿಲ್ಲ ಅಂದ್ರೂ ನೀವು ಈ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಬಹುದು. ಹೇಗೆ? ಮೋಲ್ ಕಾನ್ಸೆಪ್ಟ್ ಯೂಸ್ ಮಾಡಿ ಸಾಲ್ವ್ ಮಾಡಬಹುದು. So when we take up mole concept in stoichiometry, I'll discuss that. This is how you estimate carbon and hydrogen. Now, estimation of nitrogen. Okay, before that, one of you had asked me to explain 21 again. Let me see. 21 ಅಂದ್ರೆ ತುಂಬಾ ಹಿಂದೆ. Carbocation stability na. See, ಇದನ್ನ ನೆನಪಿಟ್ಕೊಳ್ಳಿ. Order of stability of carbocation ನೆನಪಿಟ್ಕೊಳ್ಳಿ. Tertiary, greater than secondary, greater than primary. ಆಮೇಲೆ ಯಾವ್ದು ಸೆಕೆಂಡರಿ, ಯಾವ್ದು ಟರ್ಷರಿ, ಯಾವ್ದು ಪ್ರೈಮರಿ ಅಂತ ಹೇಗೆ ಐಡೆಂಟಿಫೈ ಮಾಡೋದು ಅನ್ನೋದು ಕೂಡ ಕಲ್ತ್ಕೊಳ್ಳಿ. ಓಕೆ, ದಟ್ ಐ ಹ್ಯಾವ್ ಟೋಲ್ಡ್ ಯು. That depends on number of alkyl groups. 3 alkyl groups attached to positively charged carbon, tertiary. 2 alkyl groups attached to positive charged carbon, secondary. Only 1 alkyl group attached, primary. Illi nodi, option C nodi, there are 2 alkyl groups. So adrinda secondary. Option B, 3 alkyl groups ide, 3, tertiary. Option A nodi, 2 methyl groups and 1 ethyl group. ಸೇರಿಸಿದ್ರೆ 3 alkyl groups ಆಗುತ್ತೆ. That also is tertiary. ಎರಡು ಟರ್ಷರಿ ಇದ್ದಾಗ ಹೇಗೆ ಡಿಸೈಡ್ ಮಾಡೋದು? That's when you should take number of hyperconjugation structures. How to find out hyperconjugation structures? Easy. Find out how many alpha hydrogens are there. ಇಷ್ಟು ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ಸ್ ಇದೆ ಅಂತ ನೀವು ಫಸ್ಟ್ ಕಂಡು ಹಿಡಿಬೇಕು. ಹೇಗದು? ಇಲ್ಲಿ ನೋಡಿ, ಕಾರ್ಬನ್ ಅಟ್ಯಾಚ್ ಟು ಕಾರ್ಬನ್ ದಟ್ ಇಸ್ ಕನೆಕ್ಟೆಡ್ ಟು ಪಾಸಿಟಿವ್ಲಿ ಚಾರ್ಜ್ಡ್ ಕಾರ್ಬನ್ ಇಸ್ ಆಲ್ಫಾ ಕಾರ್ಬನ್. ಇಲ್ಲಿ ಎಷ್ಟು ಆ ತರದ ಆಲ್ಫಾ ಕಾರ್ಬನ್ಸ್ ಇದೆ? 3 ಇದೆ. 1, 2, 3. And all hydrogens attached to alpha carbon are alpha hydrogens. So count how many alpha hydrogens are there? 3 plus 3, 6 plus 2, 8. 8 alpha hydrogens. ಅದೇ ತರ ಆಪ್ಷನ್ ಬಿ ನೋಡಿ. How many? 3, 6, 9. 9 alpha hydrogens. Okay. So which is more now? 9 is greater than 8. Therefore, that will have higher, hyperconjugation structures. Okay. Right. Yes. Let's get back now. Okay. This is how you estimate carbon and hydrogen. Now let's see how we estimate nitrogen. Nitrogen hege estimate ಮಾಡೋದು? This is done by two methods. One method is called Dumas method. Dumas method. Very simple method. Principle is very simple. You convert nitrogen in the organic compound into free nitrogen gas. Nitrogen in an organic compound is converted to nitrogen gas. Measure its volume. Okay. Then, knowing the volume at room temperature, convert it into its volume at STP. Volume, room temperature volume ಎಷ್ಟಿದೆ ಅಂತ determine ಮಾಡಿ, convert it into volume at STP. It is in this equation P1 V1 into T0 by P0 into T1. This formula you will find it in gas laws. It's called combined gas equation. Nodi, P0 V0 by T0 is equal to P1 V1 by T1. P0 V0 T0 are all standard pressure, volume, temperature. P1 V1 T1 are laboratory pressure, volume, temperature. So ಇಲ್ಲಿ ನೀವು V0 find out ಮಾಡಬೇಕು. V0 ಕಂಡುಹಿಡಿಯಬೇಕು. For that you will know P1 T1 T0 P0. T0 P0 are standard values. So once you know volume at STP, then you can find out percentage of nitrogen by this formula, important formula. (28) into volume of nitrogen at STP. ಇಲ್ಲಿ ಏನು ನೀವು ವಾಲ್ಯೂಮ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿರ್ತೀರಾ ಅದನ್ನ 28 ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕು, ಡಿವೈಡೆಡ್ ಬೈ 22,400 ml into mass of organic compound, and this equation multiplied by 100 because you get it as a percentage. Okay, so very important equation formula. Now why is this 28 ಹೇಗೆ ಬಂತು ಹೇಳ್ತೀರಾ? Any one of you in the chat section, can you? Why 28 ಯಾಕೆ? Again, mass number ಅಲ್ಲ, mass number is different, not mass number. What is 28? Come on. Yes, molecular mass. Molecular mass of what? Ravi? Yes, Suchitra is right. Molecular mass of nitrogen. Molecular mass of nitrogen is 28. Good. That's about Dumas method to estimate nitrogen. Now, there is one more method by which you can find out nitrogen. It's a very popular method known as Yildahl's method. It's called Yildahl's method. Okay. Let me go to the next slide. Yes. Estimation of nitrogen by Yildahl's method. The principle here is slightly complicated, so please pay attention and understand this. Then you can find out nitrogen percentage using two equations, two formulae. Each formula to be used in a different situation. You know, the nitrogenous compound, given nitrogenous compound, is made to react with sulfuric acid. It is digested with sulfuric acid when all nitrogen in the organic compound gets converted to ammonium sulfate, ammonium salt. ನೀವು sulfuric acid use ಮಾಡಿದ್ರೆ ammonium sulfate ಬರುತ್ತೆ, hydrochloric acid use ಮಾಡಿದ್ರೆ ammonium chloride ಬರುತ್ತೆ. Then that ammonium salt is heated with a base to get ammonia. So all the nitrogen in the compound is getting converted to ammonium salt. That ammonium salt or nitrogen in that ammonium salt is getting converted to ammonia. In other words, you can say all nitrogen in the organic compound is converted to ammonia. That ammonia is again dissolved in water to get ammonium hydroxide, and amount of that ammonium hydroxide is estimated by titrating it with HCl or any other acid. Okay, ಇಲ್ಲಿ ಎರಡು ತರದ ಸಿಚುವೇಶನ್ ಬರುತ್ತೆ. Please pay attention. If you know the amount of HCl used, from that you can find out the amount of ammonium hydroxide. From that you can estimate the amount of ammonia. From that you can estimate the amount of nitrogen. ಇದು ಯಾವಾಗ? If you know the volume and concentration of HCl. But if you don't know the volume of HCl used, then you have to treat the unreacted HCl. Unreacted HCl is estimated using sodium hydroxide, standard sodium hydroxide. ಓಕೆ, ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ತಿದ್ದೀರಾ ಅಂದ್ರೆ HCl ಎಷ್ಟು ಬೇಕಾಗುತ್ತೆ ಅಂತ ನಿಮ್ಗೆ ಗೊತ್ತಿಲ್ಲ, ಬಿಕಾಸ್ ಅಮೋನಿಯಾ ಎಷ್ಟು ಬಂದಿದೆ ಅಂತ ಗೊತ್ತಿಲ್ಲ. ಸೊ ನೀವೇನ್ ಮಾಡ್ತೀರಾ, ಎಕ್ಸೆಸ್ HCl ತಗೊಂಡಿರ್ತೀರಾ. ಎಕ್ಸೆಸ್ HCl ಅಲ್ಲಿ 1 ಪಾರ್ಟ್ ಅಮೋನಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ. ರಿಯಾಕ್ಟ್ ಆದ್ಮೇಲೆ ಇನ್ನೂ ಸ್ವಲ್ಪ HCl ಹಂಗೆ ಮಿಕ್ಕಿರುತ್ತೆ. ಇಟ್ ವಿಲ್ ಬಿ ರಿಮೈನಿಂಗ್ ಇನ್ ದ ರಿಯಾಕ್ಷನ್ ವೆಸಲ್ ಆರ್ ಕೊನಿಕಲ್ ಫ್ಲಾಸ್ಕ್. ಅದೆಷ್ಟು ಅಂತ ಹೇಗೆ ತಿಳ್ಕೊಳ್ಳೋದು? ಈಸಿ. ಟೈಟ್ರೇಟ್ ಇಟ್ ವಿತ್ sodium hydroxide. That's when you'll get to know the amount of HCl, because you'd have taken a standard sodium hydroxide solution. So knowing the molarity or concentration and volume of sodium hydroxide solution, you will find out HCl. Okay, and from HCl concentration you'll find out ammonium hydroxide, from that ammonia, from that you can easily estimate nitrogen. That is the principle. Now you can use two equations in two situations. One, though ನಿಮ್ಗೆ HCl ವಾಲ್ಯೂಮ್ ಗೊತ್ತಿದ್ರೆ you can use this equation. Percentage of nitrogen is equal to 1.4 into volume of acid used into basicity. Basicity is the number of replaceable hydrogens. Andre, if you have let's say sulfuric acid H2SO4, 2 hydrogens, basicity is 2. HCl, only 1 hydrogen, basicity is 1. Atara. So basicity is the number of replaceable hydrogens into molarity. Molarity you all know is a method of expressing concentration divided by mass of substance. That will give you percentage of nitrogen. Then put 1.4 into volume of acid used up into basicity into molarity divided by mass of substance. If you don't know the volume of acid used, then how to solve it? Percentage of nitrogen is equal to 1.4 into molarity of the acid into 2 multiplied by V minus V1 by V2. So what is V? V is volume of sulfuric acid, whereas V1, V1 is volume of sodium hydroxide used. So first equation yavag use martira? If you know the volume of acid used. If not, if you are not given the volume of acid used, but if you know the volume of sodium hydroxide used, then use the second equation. Okay, that's how you find out the percentage of nitrogen in Yeldahl's method. Okay, good. Now like how you find out the nitrogen, carbon and hydrogen. Also detect halogens. Hege, by using these equations. Halogen from an organic compound can be converted to silver halide. If you know the mass of silver halide, knowing the mass of AgX and the mass of organic compound, one can find out percentage of halogen. How? Check it out. Percentage of halogen is equal to atomic mass of halogen. Chlorine ತಗೊಂಡಿದ್ರೆ 35.5, bromine ತಗೊಂಡಿದ್ರೆ 80, iodine ಇದ್ರೆ 127. Easy. Multiply by mass of silver halide, which you get in the experiment, divided by molecular mass. There's a small correction. Idu molecular mass agbeku. Molecular mass of AgX, mass of substance. The whole thing multiplied by 100. That gives you percentage of halogen. This is the equation for percentage of halogen. Neನ್ಪಿಟ್ಕೊಳ್ಳಿ, halogen converted to silver halide. Knowing the mass of silver halide and knowing the mass of the compound, you can find out percentage. Easy. Same logic is applied to sulfur. Difference ಏನು ಅಂದ್ರೆ, sulfur in the organic compound is converted to barium sulfate. ಅಷ್ಟೇ. Otherwise logic remains same. You should know the mass of barium sulfate. Knowing mass of barium sulfate as well as the original mass of the compound, you can find out percentage of sulfur here. Sulfur atomic mass ನಮ್ಗೆ ಗೊತ್ತು 32. 32 into mass of barium sulfate determined experimentally, divided by 233 is molecular mass of barium sulfate. Molecular mass of barium sulfate into mass of substance. Similarly, phosphorus is converted to Mg2P2O7. So ಇಲ್ಲಿ 2 phosphorus atoms ಇರೋದ್ರಿಂದ, 2 phosphorus atom ಇರೋದ್ರಿಂದ You should take the value as 62, not 31. Atomic mass of phosphorus is 31. But because there are two phosphorus atoms there, you should take it as 62. 62 into same mass of Mg2P2O7 divided by 222. 222 is molecular mass of Mg2P2O7. Molecular mass into mass of substance. So dear students, it is by these equations and you can estimate the percentage of elements present in an organic compound. Idr mele enen questions ide nodana. I still have around 10 minutes and I think that should be enough for this. First, question number 27. Check this out. Let me the data points. 0.2 grams of an organic compound. Carbon, hydrogen, oxygen. On combustion, on burning, yields, one second, yeah, yields 0.147 grams of carbon dioxide and 0.12 grams of water. You are asked to find out oxygen content in the substance. You are asked to find out what is the oxygen percentage. See, oxygen na direct estimate ಮಾಡೋದಕ್ಕೆ ಮೆಥಡ್ಸ್ ಇಲ್ಲ. ಸೊ ನೀವೇನ್ ಮಾಡ್ಬೇಕು, ಅದಕ್ಕೆ ಕಾರ್ಬನ್ ಪರ್ಸೆಂಟೇಜ್ ಕಂಡು ಹಿಡಿಬೇಕು, ಹೈಡ್ರೋಜನ್ ಪರ್ಸೆಂಟೇಜ್ ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಕಾರ್ಬನ್ ಪರ್ಸೆಂಟೇಜ್, ಹೈಡ್ರೋಜನ್ ಪರ್ಸೆಂಟೇಜ್ ಎರಡೂ ಗೊತ್ತಿದ್ರೆ then you can find out oxygen percentage by this method, this logic. Okay, easy. Percentage of oxygen in an organic compound which contains only carbon, hydrogen, oxygen is 100 minus percentage of carbon plus percentage of hydrogen. So ಈಗ ನಾವೇನ್ ಮಾಡಬೇಕು, you have to find out percentage of carbon, percentage of hydrogen, add it up, then subtract it from 100. So percentage of carbon ಹೇಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು? We know the formula. What's the formula? Percentage of carbon is equal to 12 into mass of carbon dioxide is to 0.147. Dear students, here is a very valuable tip, very valuable suggestion. 0.147 na 0.15 ಗೆ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ನಂಬರ್ಸ್ ನ ಆದಷ್ಟು ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಕೊಳ್ಳಿ, ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ಈಸಿ ಆಗುತ್ತೆ. ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, ಸಿಇಟಿ ಆಗ್ಲಿ ನೀಟ್ ಆಗ್ಲಿ ಎಲ್ಲೂ ನಿಮ್ಗೆ ಕ್ಯಾಲ್ಕುಲೇಟರ್ಸ್ ಅಲೋ ಮಾಡಲ್ಲ, ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟರ್ಸ್ ಯೂಸ್ ಮಾಡೋ ಹಾಗಿಲ್ಲ. ಆದ್ರಿಂದ ಮನೇಲಿ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ಬೇಕಾದ್ರೂ ಕ್ಯಾಲ್ಕುಲೇಟರ್ಸ್ ಇಲ್ಲದೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ. ನಿಮ್ಮ ನ್ಯೂಮರಿಕಲ್ ಎಬಿಲಿಟಿ ಇಂಪ್ರೂವ್ ಆಗುತ್ತೆ, ಸ್ಪೀಡ್ ಇಂಪ್ರೂವ್ ಆಗುತ್ತೆ. ಮನೇಲೆಲ್ಲ ಬರೀ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಅಲ್ಲಿ ಸಾಲ್ವ್ ಮಾಡಿ, ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಒಂದೇ ಸರ್ತಿ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಇಲ್ಲ ಅಂದ್ರೆ ನಿಮ್ಗೆ ಆ ಸಿಚುವೇಶನ್ ಅಡ್ಜಸ್ಟ್ ಆಗೋದಕ್ಕೆ ಆಗೋದಿಲ್ಲ. ಓಕೆ, ಸೊ ಈವನ್ ವೈಲ್ ಪ್ರಾಕ್ಟೀಸಿಂಗ್ see to it that you don't use calculators. But calculators ಇಲ್ಲದೆ ಇದ್ರೆ ಈ ತರ ನಂಬರ್ಸ್ ಹೇಗೆ ಡೀಲ್ ಮಾಡೋದು? Very easy, approximated, because see, options differ. Okay, you don't have to find the exact answer, approximate answer ಸಿಕ್ಕಿದ್ರು ಸಾಕು. So 0.147 ನ 0.15 ಅಂತ approximate ಮಾಡಬಹುದು. Divided by 44 into mass of organic compound 0.12 into 100. Now I'll further simplify it. See, I can write it as 12 into 0.15 can be written as 15 into 10 power minus 2. Decimal point shift ಮಾಡಿದೆ, 10 power minus 2 divided by 44 into 12 into 10 power minus 2 into 10 square. ನೋಡಿ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ಸಿಂಪಲ್ ಆಯ್ತು ನಾ. ಇವಾಗ 12 and 12 gets cancelled. 15 and 44. 44 I can take it to be 45 approximately. 15 and 45 almost 3 times. 3 times ಆಗುತ್ತೆ. Okay. Now 10 to the power minus 2 and 10 square gets cancelled. Just a second. ಏನಾಗುತ್ತೆ? This will be 100 by 3. 100 by 3 ಬರುತ್ತಾ? Let me just check it once. ಏನಾದರೂ ಮಿಸ್ಟೇಕ್ ಆಗಿದೆ ನೋಡೋಣ. 12 into 0.15 that I have taken it as 15 into 10 power minus 2. That's fine. Divided by, okay, one small mistake. ಏನದು? I have taken mass of water. Mass of water ತಗೋಬೇಕು, mass of the organic compound ತಗೋಬೇಕು. Let me just correct it. One second. I'll erase this. 0.12 ಆಗಬಾರ್ದು ಇದು. It must be 0.2. ನೋಡಿ, ತುಂಬಾ ಕೇರ್ಫುಲ್ ಆಗಿರಬೇಕು ಸಾಲ್ವ್ ಮಾಡಬೇಕಾದ್ರೆ. ನಾನಿಲ್ಲಿ ಮಾಸ್ ಆಫ್ ವಾಟರ್ ತಗೊಂಡೆ, ಇಟ್ ಮಸ್ಟ್ ಬಿ ಮಾಸ್ ಆಫ್ ಆರ್ಗ್ಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ 0.2. Then how will it change? Let me erase this as well. I'll rewrite it. 1 second. Yes. 1 second. Yeah. So again, I can simplify 12 into 0.15 can be written as 15 into 10 power minus 2 divided by 44 into 0.2. 0.2 na nanu 2 into 10 power minus 1 ಮಾಡಬಹುದು into 10 square. 10 square 10 power minus 2 gets cancelled. 15, 45 ನಾಗಲೇ ಹೇಳಿದಾಗೆ 3 times ಆಗುತ್ತೆ almost. 3 and 12 4 times. 2 and 4 2 times. So this will now be equal to 2 into 10 power minus 2 into 10 power minus 1 ಆಗಲ್ಲ. 10 power minus 1 goes to the numerator, becomes 2 into 10. Therefore 20%. Carbon 20 ಅಂತ ಗೊತ್ತಾಯ್ತು. ಈಗ ಹೈಡ್ರೋಜನ್ ಅದೇ ತರ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ. Percentage of hydrogen is given by the formula 2 into what is the mass of water? 0.12. 0.12 divided by 18 into 0.2 mass of organic compound into 100. ಅದೇ ತರ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಕೊಳ್ಳೋಣ. 2 into 0.12 as 12 into 10 power minus 2 divided by 18 into 0.2 can be written as 2 into 10 power minus 1 into 100. 2 and 2 gets cancelled. 10 power minus 2, 100 gets cancelled. 6 2 times, 6 3 times. This will be 2 by 3 into 10. 20 by 3, which is 6.66. So carbon 20%, hydrogen 6%. 20 plus 6%, 26%. So carbon hydrogen ಸೇರಿ 26% ಆದ್ರೆ oxygen ಎಷ್ಟಿರುತ್ತೆ? Remaining 73% almost. Yes, that should be the answer. 1 second. Let me mark it. See, carbon 20%. 1 second. Yeah, let me highlight the answer. Carbon 20%, hydrogen 6.6%. So total 26.6. ಅಂದ್ರೆ ಆಕ್ಸಿಜನ್ ಎಷ್ಟಿರಬೇಕು? 74% ಇಂದ ಸ್ವಲ್ಪ ಕಡಿಮೆ ಇರಬೇಕು. ದಟ್ ಇಸ್ ಆಪ್ಷನ್ ಎ. ಈಸಿ. ನೋಡಿ, ನಾವೇನು ಎಕ್ಸಾಕ್ಟ್ ಆಗಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿಲ್ಲ. ನೀವು ಎಕ್ಸಾಕ್ಟ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಟೈಮ್ ವೇಸ್ಟ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ದಿಸ್ ಅಪ್ರಾಕ್ಸಿಮೇಷನ್ ಮೆಥಡ್ಸ್ ಯು ಶುಡ್ ಲರ್ನ್. ಓಕೆ, ದಟ್ಸ್ ವಾಟ್ ಇಸ್ ಸಿಇಟಿ ಅಂಡ್ ನೀಟ್. ಎಷ್ಟು ಬೇಗ ಅಕ್ಯುರೇಟ್ ಆನ್ಸರ್ಸ್ ನ ನೀವು ಡಿಟರ್ಮೈನ್ ಮಾಡ್ತೀರಾ ಅನ್ನೋದ್ರ ಮೇಲೆ ನಿಮ್ಮ ರ್ಯಾಂಕಿಂಗ್ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ಓಕೆ, yes, let me go to the next question. Let me see how many more minutes I have got. Yes, we have almost come to the end of the class. We'll just solve this. Question number 28. 0.24 grams of the organic compound gave 22.4 liters of nitrogen at STP. What is the percentage of nitrogen? Okay, very simple. ಇಲ್ಲಿ ನಾವು ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡದೆ ಹೇಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು ತೋರಿಸ್ಕೊಡ್ತೀನಿ ನೋಡಿ. Percentage of nitrogen is nothing but mass of nitrogen over mass of organic compound into 100. ಅಷ್ಟೇ. ಮಾಸ್ ಆಫ್ ಆರ್ಗ್ಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ ನಮಗೆ ಗೊತ್ತು 0.246. ಈಗ ನಾವು ಕಂಡು ಹಿಡಿಬೇಕಾಗಿರೋದು ಮಾಸ್ ಆಫ್ ನೈಟ್ರೋಜನ್. ಹೇಗೆ? ಯು ಕ್ಯಾನ್ ಯೂಸ್ ದಿಸ್ ಕಾನ್ಸೆಪ್ಟ್, ಮೋಲ್ ಕಾನ್ಸೆಪ್ಟ್. ಸಿ ದಿಸ್ 22,400 centimeter cube will have a mass of 28 grams nitrogen gas. 28 grams. Andre 22.4 is how much? Easy. 22,400 is 28 grams, which means 22.4 is how much? So 22.4 is 1,000th of this. 22,400 na 1,000 ಇಂದ ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ 22.4 ಬರುತ್ತೆ. Similarly, divide 28 by 1,000, you get 0.0828. So mass of nitrogen is 0.028. Now replace that here. Percentage of nitrogen is equal to mass of nitrogen 0.028 divided by mass of organic compound 0.246 into 100. That's easy. Now this will be 2.8 divided by 0.24 into 100. Now please observe 2.8 and 0.24. 2.8 and 0.24, almost 10 times, because 0.24 into 10 is to 2.4. 0.24 into 10 is 2.4, which means 0.24 into a number slightly greater than 10 must be 2.8. So, which is a number? Which option here is slightly greater than 10? 11.38. Option A will be the answer. Nodi? 11.38. Now, ಮತ್ತೆ ಹೇಳ್ತಾ ಇದ್ದೀನಿ 11.38 ಅಂತ ನಾವು ಎಕ್ಸಾಕ್ಟ್ ಆಗಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿಲ್ಲ. We just approximated it. Is it clear? We just approximated it. Okay? To be 11.38. So ನೀವು ಹಾಗೆ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಎಕ್ಸಾಕ್ಟ್ ನಂಬರ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದಕ್ಕೆ ಹೋಗಬಾರ್ದು, ಟೈಮ್ ಕನ್ಸ್ಯೂಮ್ ಆಗುತ್ತೆ. You can follow this approximate methods. ನೋಡಿ 2.8 by 2.24. 2.8 by 0.24. Okay? So this is not multiplied by 100 again. 0.24 into 10 is 2.4. So 0.24 into 11 would be slightly closer to 2.8. That's how you figure it out. Yes? That is question number 28. No, if you can solve one more question. Yes, I think these two questions. There are two questions which takes around 10 minutes for me. Idanna now mundin class ge itkolona. Now we'll conclude this. We'll meet next week again with a new chapter. That will be carbons. Again, a chapter from your first PUC. Okay. Thank you all of you. Have a nice weekend.